Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So we are given an easy problem of longest harmonious subsequence. We define a harmonious array as an array where the difference between the maximum value and the minimum value is exactly 1. So you can understand there can be at most 2 elements in the subsequence. So exactly 2 elements must be there, and given an integer array nums, return the length of the longest harmonious subsequence among all its possible subsequences. So if you see your subsequence, whichever subsequence you are selecting, okay, so that must have at max 2 elements, because if something like 2 and 2 3, more than 2 elements, two distinct elements, suppose 5 is also there or some 4 is also there, you see the difference between the maximum and minimum and maximum value, that difference will be greater than 1. Okay, so that in order to maintain that to be exactly 1, there should be exactly 2 distinct elements in the subsequence, and the subsequence length should be maximum possible. So let's try to understand with this with an example of how this works. 1 3 2 2 5 2 3 7. So if I take this example, okay, 1 3 2 2 5 2 3 7. So if I take this example, the subsequence they are selecting is this 3 and 2. As you can see that this 3 and 2 is having the difference of exactly 1, and their length of this subsequence is 5, and that is the maximum possible. So can you think how to approach these things? So you can understand that we need the frequency of the, let's say, an element x and an element x plus 1. You can understand this easily, right? If I am selecting an array element x and x plus 1, then I need their frequency, and sum of their frequency should be the maximum possible, the sum of their frequency. So from this frequency idea, we got to know that we need to store it in a map. Okay, so in a frequency is calculated in a map. So I try to calculate the frequency of map. So let's say this frequency of 1 is 1, frequency of 2 is 3, frequency of 3 is 2, frequency of 5 is 1 here, and again 7 is 1 here. So then I can easily keep an answer maximum variable. Okay, I can maximize this answer starting from 0. I will just iterate through all the elements of the map. I just iterate through all the elements of the map and just check whether, let's say I am currently at the element key comma value pair. Okay, so I will just check that whether key plus 1 exists in the map. Okay, the count of this element is greater than 0 or not. If it exists, okay, if it exists, then I will just do this maximum value answer equals to this maximum value of answer comma, what should I do, comma, this value pair, currently the value, and the sum of this map of k plus 1. I hope you understood this. Okay, because map of k plus 1, why? Because this is the frequency of the k plus 1th element, and this is the frequency, this value is the frequency of the kth element. Okay, not kth element, the element k. Okay, the element k. So key comma value pair, I can just iterate through the map, and I can just do this and check it, and that will be sufficient. It will be a short code, I guess. So let's try to put stuff. Let's have an integer n nums dot size, and also have an integer answer which is initialized to 0 initially. And what we can do, we also need to initialize a map. So this map will store all the frequencies of this nums. So I can go through this elements x. Okay, and these elements x, I can just store it in the map. So I am storing it in the map. I'm just incrementing the frequency of x. So in this way, this frequency is getting stored in the map. And now what I want to do is very similar, pretty easy. I want to iterate through the map. So all of you know how to iterate through the map, right? For auto, this key comma value. Okay, as I told you, key comma value. This is how we iterate through a map. And if you see in this key comma value pair, if I want to check now that whether this map dot count of 2 plus 1, the difference should be 1, so one more element, this element, if it is present in the map, so if the count is greater than 0, okay, if this count is greater than 0, then what should I do? I should do store in my answer that store as the maximum variable, this answer max, and I will also take v plus this map of k plus 1. So you understood this, I guess. This map of k plus 1 is nothing but the frequency of the k plus 1th element, and k plus 1 element k plus 1, and this v is the frequency of element k. Okay, so the element k. So I just add these two frequencies. That will be my length of the subsequence. Okay, because I hope you understood. We just need to return answer now. So how is this working? It's easy to visualize, but let's say you traverse through the map. You initially you have one, so you add the frequencies of one and two, so you get four. Okay, you get the answer as four if you add the initial frequencies of one and two. Then you start with, then you go to two and add the frequencies of two and three. You get five. Your answer is now five. That is the maximum value. You add the frequencies of three and four. Four is not there in the array, so the frequency of three and four addition is two. So we don't have anything better. Then 4 and 5, again it's 1. 5 and 6 is 1. 6 and 7 is 1. So we don't have anything better than 5. So that's how our answer is coming to be 5. So that's all the code. That's all the code we need to write. So let's try to run it. Let's try to run it and check. Uh, so see, we have a compiler error because this num does not exist. I did a spelling mistake here instead of num. So see, we have the accepted thing now. Let's try to submit it and check if it really works for all the test cases. So you see, we have the accepted case. Our runtime is not so good. So if I try to write this in unordered map, do you think it will be any better? Do you think it will be any better? Unordered map means it will be amortized of one complexity. So let's check if it goes somewhere better, somewhat better. Yeah, it's somewhat better, but not very good. And this thing is not that much accurate always. For the same solution, it may give varying results also. So whatever be the case, this was definitely an easy problem for today. And I hope your day goes also as easy as the problem. Thank you so much.